Electronic configuration shows the arrangement of electrons in an atom. To write electronic configuration, we use Aufbau's principle. This principle states that electrons are filled into orbitals of lower energy before orbitals of higher energy. The principle is illustrated using this diagram. In the diagram, the numbers represent energy levels. The letters represent the orbitals present in each energy level. There are 4 main orbitals. S orbital holds a maximum of 2 electrons. P orbital holds a maximum of 6 electrons. D orbital holds a maximum of 10 electrons. And F orbital, which holds a maximum of 14 electrons. Electrons are filled into orbitals following the arrows in this order: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. Once you follow this order, electronic configuration becomes mechanical and not confusing. 3d orbitals are included if you are dealing with a transition element. Let's take an example. Write the electronic configuration of sodium. Sodium has an atomic number of 11, so it has 11 electrons. Using the Aufbau's principle, 1s takes 2 electrons, 2s takes 2 electrons, 2p takes 6 electrons. Together we've used 10 electrons. It remains 1. Then the remaining 1 electron goes to 3s, and the final answer looks like this: 1s2, 2s2, 2p6, 3s1. Note that the amount of electrons filled is based on the maximum each orbital can take. The remaining electrons, if any, are filled in the subsequent orbital. Let's take another example. Write the electronic configuration of titanium. Titanium has an atomic number of 22, so it has 22 electrons. Using Aufbau's principle, the electronic configuration will look like this: 1s2, 2s2, 2p6, 3s2, 3p6. Then, looking at the illustration, 4s is filled before 3d. So we continue: 4s2, and then the remainder goes to the 3d orbital, so it ends with 3d2. Always remember, 4s fills before 3d. This is the fast method to write electronic configuration of elements. If you have any questions, please leave them in the comment section below. Like, share, and subscribe. Thanks.